Welcome, Matt Taylor here with a video on how to do question 12, the last question for 1.4. It's in the extended answer, and according to the sheet I got from my methods teacher, it's the last question. It's optional, it's if you have time, but this will save you time, me showing you how to do it now. So, I'll read the question. The town planners of a country town are considering constructing a road that will allow for travellers to bypass the town. The road will be constructed through bushland outside the town. It can be modelled by y equals a, bracket x take h, bracket, to the power of 3 plus c, where x and y represent the number of kilometres due east and north, respectively, from the centre of the town. The point of inflection for this model occurs at 5 and 2. So the x coordinate's 5, the y coordinate's 2. So we can see from the diagram they've got on the side here, it's a cubic, because it's power of 3, and we can see that. So the middle point here is the point of inflection. We do know that the coordinates of that, 5 and 2, and from that we can easily find the answer to question A that says find the value of h and c, because you'll know from the previous work in this chapter that 5 goes in here where the h is. If it was a negative 5, then that will become x plus 5, but because it's x take 5, it moves it to the right 5 units, and plus c, you put the 2 in there, so h is 5, c is 2. For B, given that the new road will join up with the main road of the town at point 12 kilometers due north of the centre, excuse me, find the value of A. So when it says given that the new road will join up with the main road of the town at a point 12 kilometers due north of the centre, it's referring to this point here. It's basically saying that is 12 on the y-axis. And you may think you've only got 1 point from that, but because it's an intercept, we know that the x is 0 and the y is 12 when at this point here. So if we substitute in 12 as the y and x as 0, we can solve for a, because that'll be the only variable left. So this is our initial equation. You got h is 5 and c is 2. Put those in, and then we put 12 and 0 in. And what happens now is the way the BODMAS works is you have to take the 2 out first, so it becomes 10 equals a, bracket 0 take 5 cubed. 0 take 5 cubed gives you negative 5 times negative 5, which is positive 25. Multiply that by another negative 5 and you get negative 125. So 10 equals negative 125a. Then you simplify that, and you end up with 10 over 125, or negative 2 over 25, as you can see in this finished equation here. How far due east of the town centre will the proposed road commence? So here's the town centre. Due east is running along the x-axis, so it's asking what is the x-intercept of the equation. Now, it doesn't have the no technology thing here, so the quickest way, I think, since we just worked out the equation, is to graph it. So that's what I've done, and I've used graph trace, and it tells you the point is 7.92. So it's 7.92 kilometers east of the town centre. The town planners decide that the whole proposed model road needs to be moved a further 3 kilometers east. Find the equation of the new model. So as I said before, the number in here changes where the point of inflection is on the horizontal plane of motion. So to move it 3 kilometers east, all you need to do is change this 5 to an 8, because 5 plus 3 is 8 obviously, and from changing that to a 5 to an 8, you'll move it 3 more units across, or 3 more kilometers east, like the question asks. So the new equation of the model is simply this. The 5 changes to an 8, and everything else stays the same. How much further north will this new proposed model road meet up with the existing north-south road? So what it's asking, this is the north-south road, the y-axis, and this road currently hits the y-intercept here. If they move the graph across, the graph will have more time to go up before it hits the y-axis, so the y-intercept will be higher. So what it's asking is what is the y-intercept of the new road that they're putting in. So basically we can graph it again. I have done that. I've put it in here. Putting this in here also defines it as f2. So what I did is I used f2, and then I want the y-intercept, so you make x 0, and you come up with 42.96. But the question asks how much further north will the new proposed model meet up with the existing north-south road. So you basically have to get the y-intercept of the new equation and subtract it from the y-intercept of the old equation, and that'll give you the difference between the two roads. And that's what I've done there. F2 0 because the x is 0, take f1 of 0 because both x's are 0, we want the y-intercepts, and you get 30.96. So yep, that's how you do question 12. Hope that helped. Thanks for watching, see you in another video.